Hi.
Hi, hello. Are we
Hi.
live?
Sorry?
I think we are live.
Yeah, I think Happy said that we were live.
Okay, so hello everyone. Thank you for waiting. We faced many technical difficulties today. Thank you for waiting for us. Today we'll be joining with the sixth episode of CS101. I welcome our guest Bhavana Jain. She is an alumni of IIT Hyderabad. Currently, Bhavana is pursuing masters from University of Illinois at Urbana-Champaign. Previously, she had worked as a software developer intern at Google, a research intern at Purdue, and also at AI resident at Facebook AI Research. So we'll be welcome Bhamna, very well welcome. Thank you for waiting. Sorry for the technical difficulties.
Yeah, no problem. Stuff happens. Yeah, thanks so much, everyone, for waiting, and we apologize for the inconvenience. Um, cool. Hi, I'm Bhavna, and I'm currently a master's student in the computer science department at UIUC. I mostly work in the area of artificial intelligence and systems. Yeah, so that's a little about me.
So, I know you're pretty much excited to talk about the your work that you did in the Facebook AI research and also the research intern that you did at Neuro AI.
Right.
But before moving on to the that chapter of your journey, we would like to know about uh, your IIT Hyderabad journey. So that shaped you into what you are today. So can you tell us more about that?
Yeah, I think IIT Hyderabad was special because, in every person's life, their undergrad journey, those 4 years, are special because they help shape your character and they define you as a person. Um, IIT Hyderabad is definitely special because before coming to IIT Hyderabad, I did not know how to code. So I started my journey of computer science at IIT Hyderabad. And I think there are a lot of great points about IIT Hyderabad. The first being that the faculty at IIT Hyderabad is outstanding. I think the content of some of the courses that we studied at IIT Hyderabad is at par with some of the top US universities. And there's a diverse set of faculty, which means that there are a lot of research areas that are being worked on. So there's a lot of like room for students to explore and try out different opportunities. The other thing that really helped me was we're a couple of years old. I think we started in 2008,
Right.
but we have this very strong culture of where seniors help juniors. I think when I was doing my grad school applications, I received a lot of help from seniors about how to approach different professors, even like what the structure of your SOP should be, reviewing your SOP, so on and so forth. So that is really special. The other thing that worked out really well for me was I was a web coordinator for Elan in my second year. And so that gave me a very early exposure to development. And um, then I had like a pretty solid project on my resume where I had worked on some front end, some design, and some back end. Um, Other than that, I think there's fractal academics in which like students are
Right.
exposed to core areas of their branch pretty early on,
Pretty early on, right.
and so that gives you like a breadth view of what your field is like. And you can you can also have like some very interesting initial projects under your belt, and that really helps when you're applying for internships. For example, I did an internship in second year, and all of these factors I think really helped me out and made me stand out of the other applicants.
Great. Good to know. So moving forward, we would like to know more about the research work that you did at Facebook AI Research. So can you tell us more about that?
Sure. I will present my screen because I've prepared some presentation. So let me know if you can see my screen.
Yes, we can see screen.
Okay, cool. Um, right. So I was an AI resident at Facebook AI Research from June 2018 to 2019. And during my time there, I worked on autonomous navigation in 3D environments. I'll explain what I did in the next few slides. I just want to take a moment to note that the work that I will present here has been done by a large team, and I only speak on behalf of all of them. So we all know that deep learning has led to a lot of progress in vision tasks, for example, image classification, semantic segmentation, and even language tasks in which, like you convert a sentence from one language to the other, or speech to text, etc. But the community has been seeing a shift from AI tasks based on like static data sets that are curated from the internet. So, for example, like a data set of images, a data set of speech, audio, to embodied AI tasks. Now, in embodied AI tasks, you have an agent that actively perceives the surroundings. So it will interact with the surrounding, plan how to navigate in that environment, and communicate with people using natural language processing. So I have a small video to sort of help us understand what that is like. So you can give me one second. So you can ask the agent to navigate to particular target coordinates, or you can ask the agent to navigate to a target object, like we see here, or it can
So it
navigate.
can,
Sorry.
yeah. So I was just, it can even, you can even ask questions to the agent, and can it give you answers?
Yeah. So those are the kind of tasks that come under embodied AI, and our team itself was working on the embodied question answering task. So it'll come up later in this video. Yeah, you can ask it to navigate to a particular room or area in the environment, or you can constantly like interact with the agent and ask it to follow your instructions. And this is the question answering part that you were talking about.
Right.
So it says, what color is the TV stand? So the agent has to first navigate and find out where the TV stand is, and then answer the question about it. Right.
Pretty interesting.
Yeah, so these are the kind of tasks that people are moving towards, these interactive embodied AI tasks. And so the thing to note here is the agent, the virtual agent or the robot, does not have access. Sorry, give me one second. Yeah, so the virtual agent does not have access to like a global map or state of the environment, and it has to navigate solely based on the visual sensors. So these agents, they're equipped with a camera sensor from where you can get RGB images, and it is equipped with lidar sensor, where each frame, from the lidar sensor, each pixel will tell you how far that pixel is from your current location.
So basically, the depth of the object or the
Yeah.
distance.
So how far are objects from you if you look at this current frame? So if you have a table nearby, the values in that area, the values of the pixels in that area will be smaller, because there's an object close by. And so I think throughout this presentation, I will refer to the term embodied AI tasks and autonomous navigation tasks interchangeably.
Okay.
Um, Now, following this shift in trend, where we moved from static internet AI tasks to interactive embodied AI tasks, the team's vision was to build the ImageNet or COCO kind of a benchmark for embodied AI. So there has been tremendous progress in vision tasks, but the key factor to that was having like a standard data set, like a same data set on which everybody tries their approaches, and now you can compare which approach does well, right? You can
Right.
compare these approaches. But in the embodied AI space, what was happening was everybody was working on their own like 3D data sets, um, and so it was very difficult to compare different approaches, right? Some people had longer episodes, some others had shorter episodes, and this just makes it difficult to compare different approaches. So there was a need to sort of create a simulation platform, have like standardized data sets, standardized metrics, so that we could consistently evaluate these navigation agents. And hence, we built Habitat AI, and it consists of two layers. The first layer is Habitat Sim, which is a high performance simulator that can support multiple 3D datasets. Um, Right. So when I say it was high performance, just to give you an idea of how high the performance was, Habitat Sim can achieve like a FPS, frame rate of a couple thousands per second, which was an order of magnitude higher than what the previous simulators could achieve, which was on the scale of a couple hundreds per second. And with this increased speed, with this increased frame rate, we were able to do some interesting experiments that I will talk about in the next few slides. Now, coming back to the second piece in the software stack, Habitat Lab. So this is like a Python front end so that you can interface with the simulator that was written in C++. Python is much easier to use. It has been widely adopted by the ML community.
Right.
And you can also like define abstractions on top of it, right? So what is a data set? What is a task? What is an environment? um, Define different kinds of tasks. As I said, there was point goal navigation where you navigate to certain target coordinates. There's object goal navigation where you navigate to certain target object. So once you define, so you can define. So Habitat Lab lets you define all of these tasks, and we also published like some baselines, some algorithmic baselines to solve these problems as a part of Habitat Lab. Right. Now, once we had built the platform, we performed multiple experiments to sort of use the platform and test it. And for simplicity, we chose point goal navigation as our first task. Now, in point goal navigation, the virtual agent, sorry, the virtual agent has to.
Your screen is not visible.
How about now? Wait, let me present again. Sorry about
Yeah,
that.
no issues.
Is it visible now?
Yeah. Yes.
Wait for a couple of seconds.
Huh,
Okay,
it's visible.
I'll start from the start for this.
From the point goal navigation.
Yeah. So once we had built the platform, AI Habitat, which, as I said, consisted of Habitat Sim and Habitat Lab, we performed a bunch of experiments to use it and test it. And for simplicity, we started with the point goal navigation task. In point goal navigation task, there's a virtual agent. It is spawned at some source coordinates, and it is asked to navigate to some target coordinates. Now, as I said, the virtual agent does not have um, access to any kind of like global map or state
Right.
of the environment, and it only has access to the visual sensors like the camera and lidar. And we have different types of agents based on what visual sensors it can access. So when I say RGB agents, I mean agents that can only access frames from the camera sensor.
Right.
uh, Depth agents, they can only access frames from the lidar sensor. um, then we have RGBD. They can access frames from both the camera sensor as well as the LiDAR sensor. And we evaluated another agent called Blind. Blind basically does not have access to any visual sensor, but so apart from the visual sensors, we also at every time step we give the relative coordinates, like how far the goal is and what is the orientation of the goal with respect to your current orientation. So at every time step we give that to the agent. So even if you don't have access to visual sensors, you can still pick up on that cue. But since you don't have any visual sensors, you might bump into a lot of obstacles,
Obstacle.
and so that is the expected behavior from the blind agents. So now, yeah. So for example, in this top-down view, blue, the blue point is the source coordinates. The red point is the target coordinates, and we've just I'm just showing you this top-down map so that we can understand. But the agent does not have access to this. It only has access to these RGB and depth frames, right?
Right.
Right. Now, the evaluation metric that we use for these kind of tasks, it's called SPL, which stands for success weighted by path length. Now, if the agent does cannot reach the target coordinates within a budget number of steps, then it is assigned a score of 0. Let's say the agent does manage to reach the target coordinate, then the score that is assigned is actually a ratio of the length of the shortest path distance between the source and the target divided by the length of the path that the agent took. So, for example, in this figure, the green path is the shortest travelable path between the source coordinate and the um, target
Target
coordinates,
audience. Yeah.
and this blue path is the one that has been taken by the agent. And now, since like they almost align, in this case the SPL would be like very close to 0.99, right?
Right.
But if the agent takes a lot of steps to reach the target coordinates, then the score will be lower because the length of the path that has been taken by it will be much higher than the shortest path length,
Right.
right? Moving on. Sorry. So, in literature, in this embodied AI literature, there are two kinds of approaches to autonomous navigation. First is the classical SLAM-based approaches, shown in the left here, and the second one is learning-based. So, for example, reinforcement learning-based approaches. Now, in so I'm just going to give you an overview of what is the difference between these two kinds of approaches. So, in the classical approaches, the agent will navigate the environment. So, it will try to explore the environment and simultaneously try to build a map based on what it is seeing. So, these approaches they called SLAM, which literally stands for simultaneous localization and mapping. So the agent can keep track of how much it is moving, so it can calibrate its movement and try to map that with what it's seeing in a 2D map, 2D top down view. So, for example, in this, as you see, the agent is moving and exploring different regions. Now it knows where the free spaces are, and hence it can build like a partial map of the environment. Now, once you build that partial map, you can try to come up with the best action towards the goal. So, those are the classical approaches. In learning based approaches, what happens is the agent interacts with the environment using certain actions. So, in our case, the actions were to move forward, to turn left, to turn right, or to stop, right? And so the agent will interact with the environment using these actions, and upon taking a particular action, it receives a new state and a reward, right?
Right.
So, if it takes like good actions, then it will receive a reward, otherwise, it will receive a penalty. Um, Yeah. So these RL based approaches they rely on the reward or the penalty received from the environment to sort of come up with a good navigation policy. Now, with the previous experiments in literature, it was known that the classical SLAM approach, which is shown in green over here, can outperform the learning based approaches. But the catch is the previous simulators were limited to only 5 million steps of experience because their frame rate was very low. Now with Habitat we were able to increase the frame rate by an order of magnitude, and hence we were able to also scale the the amount of experience that the agent can have in all these experiments. So when we scaled it to around 80 million, we observed an opposite trend. So initially, you can see that SLAM beats all the learning-based
Learning.
agents. But as you continue to train it, for when you scale your experiments, somewhere around like 30, 40 million, you have these agents that are equipped with depth sensors. So this I think it's the cayenne color. This is the agent that is equipped only with the depth sensor. This is the one that is equipped with both RGB and depth. So the agents that are equipped with depth sensor they can outperform the classical SLAM based approaches when you scale the scale your experiment,
This
right?
result looks pretty interesting. So, the
Yeah.
red one is the RGB with depth, so visual
Mhm.
and depth. And the green one is only with depth.
The
With
green one is the SLAM, the classical SLAM approach.
okay, okay, the cream, the upper one, the only depth one. It is outperforming the RGBD.
Yeah. So
So
wait.
we
So
have extra information in RGBD. That is the
yeah.
visual.
So
It
that's
sounds
actually
counterintuitive.
yeah. That's actually a very interesting question and something that we were also baffled by. I mean, the agent could just ignore the pixels or the information coming from the camera, and it would perform as good as this depth agent, right? But we believe that RGB is this high entropy signal, right? It's just colors, and when it comes to point goal navigation, what you really want to know is where is the free space in the environment, right?
Right.
And with RGB, it's just a bunch of colors, and that does not make any sense for at least like point goal navigation. If it was semantic navigation, where you have to travel to a particular object, then RGB adds a lot more information. But for point goal navigation, really RGB is just a high entropy signal that is doing nothing but distracting the agent. And hence you can see that the agent with RGB is the performance is almost comparable to the blind agent, because the RGB signal is not helping it, so it cannot decipher anything about free space just based on the RGB signal. And it is only when it is equipped with depth that we see it do interesting things,
Right. Okay.
right? Okay, cool. Moving on. So, as I mentioned, the two unique selling points of Habitat Sim were the high performance, and we saw the kind of opposite trends that we were able to obtain just based on its high frame rate. The other unique selling point of Habitat is that it can support multiple 3D datasets. Now, all the simulators prior to Habitat were designed for like one particular 3D dataset. So it was very hard to train an agent in one 3D dataset and just test it on the other 3D dataset.
Right.
But as you might know, generalization is like a very important concept in machine learning. Like, how well does your approach generalize to other datasets, right? So, for example, if I have an agent that can navigate in a Gibson, so Gibson and Matterport 3D, so MP3D stands for Matterport 3D. So these are the two 3D datasets that we tried. And what we basically did here was trained an agent in one dataset and tested how well it does on the other dataset without like fine tuning
Fine
or
tuning.
right. And so we were uh, because of Habitat, we were the first ones to be able to do such kind of generalization experiments. And we observed that agents with that are equipped with depth sensors, that is the depth and the RGBD agent, they can generalize very well, but the other agents can't. So this was an interesting observation. So we submitted a write-up of the technical details of Habitat and the observations that we saw from these two experiments, and submitted it to ICCV 2019. And over there, Habitat was nominated as a candidate for the Best Paper Award.
Oh, congratulations.
Yeah, thanks. Yeah, I mean, it was a team effort. So yeah, so this is about my work at FAIR.
So I had just one question regarding the, so what you tried to do was create data sets on 3D data sets so that it can be generalized and people can use it, like Coco and the image data set.
So rather than creating data sets, I would think of it as creating a software stack. So AI Habitat, so when you say ImageNet and Coco, so ImageNet and Coco is a benchmark that everybody uses to evaluate how good their approach is for image classification and semantic segmentation or
Right,
captioning, right?
right,
Um, we wanted to do something similar for embodied AI, right? Have a standardized data set, maybe like 1,000 episodes in Gibson that we would use for point goal navigation, and see and compare how well these different approaches are doing on that data set of 1,000 episodes, right?
right,
And so to do that, we need to provide a simulation software that can render all these scenes from the Gibson dataset. We need to provide the Habitat lab that can load these 100 episodes that I'm talking about, and you can hook up your approach with Habitat lab to see how well it is doing. So the standardization is about having like a good simulation platform, having standardized data sets, and a standard metric to evaluate these agents.
right.
Does
So,
that answer your question?
so coming to the standardized data set, so can we create a real world data set using the simulation? So
Can we?
if you want autonomous driving car, so
Hmm.
we ultimately you would want the car to perform in the real world scenario. So
Right.
the simulation, does it create the data set at the same level of accuracy as the real?
So, so the thing is, all of these data sets that I'm showing you, it's basically like somebody went and scanned people's houses, and we store that data set, as textures and There are different formats, and simulator will take that scanned data and then render it as an environment. So these are actually people's houses that you see here.
Okay.
um, and they've we're just rendering them in a simulation platform.
Okay.
I think you were thinking the other way, like, these are simulated and then how do we transfer.
And then to translate into the real world.
No, but these are real houses, that somebody went and scanned, and now we're loading it up
Okay.
in habitats. And
So like, there might be challenges with the real world data set too, right? You can't actually go on and create a real world scenario of a person driving the car and making the false cases like this should not be allowed and this should be. So it's pretty costly.
yeah. So the
It will be easier
objective.
in simulations to do that.
Can you repeat that?
I think it will be easier in simulations to create data sets like that.
Right. So in simulation, you can, like, do anything that you want, right? So the final goal is to have all of these agents act in the real world, but it's very difficult to conduct experiments in the real world because, number one, it's expensive. You cannot parallelize things. Plus, it's dangerous, right? These robots, for example, consider a self-driving car that does not know how to drive yet, and you just leave it on the road. It's going to hurt people, right?
Right.
So you cannot train directly. I mean, it's very expensive to train directly in the real world, and it's dangerous also. So what you try to do is create a simulated view of the same environment, try to train your agents there, and once it is trained, transfer those skills onto the real agent, onto the real physical robot.
Right. That's true.
Do you have any more follow-up questions?
No, I'm good. Think if people have their questions, they can actually post on the Slido link. So we can take them up at the end.
Sure. Do you want me to open Slido?
No, wait, just let's see. We can move on. We'll probably take the Slido's questions after at the end.
All right. Um, I don't know. Should I just carry on with the presentation that I had?
Yes, please.
Okay. Ouch. Okay. So next up, I am going to talk about Neuro AI. I was a machine learning research intern at Neuro AI, and Neuro AI is basically a self-driving car startup that focuses on last mile delivery. So things like restaurant takeouts or grocery deliveries. So this car does not transport passengers, but rather it just does restaurant takeouts and deliveries. And I worked on two projects in the trajectory planning area. First was integrating their imitation learning pipeline and reinforcement learning pipeline. And once I had integrated those, I trained a bunch of agents and analyzed their behavior. I'm going to elaborate this in the next two slides. So just hold on to that thought. The second project that I did was I implemented a recurrent neural network architecture in their distributed reinforcement learning platform. Right.
Right.
So let me explain what I did in my first project in a little more detail. So, so let's start with a background of what imitation learning and what reinforcement learning is. So in imitation learning, you train the network to mimic some kind of expert behavior. So imagine that there's a human that is driving the car. So the car is collecting the data, from the different sensors, and we have what the human did in these different situations, and now we want the network to pick up on these cues and try to learn how to drive. Right? That's
Right.
imitation learning. Whereas in reinforcement learning, what happens is a network will try to interact with the world, and when it interacts with the world, it will take a particular action, it will receive a new state and a reward based on that action. And based on, if the reward is positive or negative, it has to decipher what is good behavior and what is bad behavior. Right? Now, a common problem that happens with imitation learning training is your network might, so since your network can't perfectly mimic the expert behavior, you will always have some errors, right? So these errors add up, and your network might get stuck in a situation that has not been seen in the expert trajectory. So to give you an example, in expert trajectories, the drivers will always like drive, in the center of the lane. But since your network does not perfectly mimic that behavior, it might find itself on the edge of the lane, or maybe like a little bit outside the lane, and now it does not know how to get out of such situations. uh, so to remedy this, a popular approach is to bootstrap or first train models with imitation learning, and then fine tune it with reinforcement learning. And the hope here is that we will get the model, started on what good behaviors are, so it does not waste a lot of time trying to acquire what good behaviors are. But there's also enough randomness during the reinforcement learning phase that it, is forced to be in a tough situation, and it learns how to overcome those situations, right? Now let's talk about the trajectory planning. It has three steps. The first step is behavior planning. In behavior planning, the model will try to generate some low level trajectories. So it will generate a pair of XY coordinates over the next, say, 10 or 20 time steps, right? So this is like a rough trajectory. The second stage is the ILQR planner, which will refine these low level trajectories using some constraint optimization. So for example, there's like a speed limit on a particular patch of the road, or making sure that you're not passing too close to the other vehicles. So there are all these constraints, right? So ILQR planner will take care of them and refine those trajectories. And the last stage is motion selection, where you have a reinforcement algorithm that will pick the best refined trajectory that has been output by the ILQR planner. So among all of these different trajectories, it will try to select the best one. Now, in the behavior planning stage at Neuro, they were using hand engineered plans. So, hand engineered, you can sort of think of it as rule based plans. You have different plans like, where you just go, or you go slowly, or you stop, or you pull over to the side of the road. But the team wanted to move to like machine learning generated plans, and they had a new model where they trained a model based on imitation learning to generate these plans. I think. Can you see my?
No, your screen is not visible.
Yeah, sorry. Um, sorry. I think it is because I did not interact with it for a long time and it just locked me out. Okay, so there were all these rule-based plans, right? Go slow, stop, pull over, and the team wanted to move to like machine learning generated plans, and they had this new model that they trained based on imitation learning that was generating these plans. So my project was to integrate this new model with the rest of the pipeline, and then train different resulting models and analyze their behavior. Now, one common problem when it comes to analyzing, like in trajectory planning in self-driving, is that there's no good metric to analyze behavior. It's still largely a manual process. Like, I'll have to look at the trajectories and see if the car has done something fishy. I mean, you can have some crude metrics like did it follow all the traffic rules, um, right? But still, like when you're thinking about behavior, it's still very qualitative, and there's no good metric to capture that. So a lot of like behavior evaluation is still largely manual, where humans have to sort of there are humans that have to go through the trajectories and see what kind of a behavior your bot is displaying. Is it too aggressive? Is it too conservative? Does it get stuck a lot? So on and so forth. The second project that I worked on was implementing this recurrent neural network architecture in their distributed RL platform. Now, recurrent neural networks, they're a popular choice for sequential tasks.
Right.
So examples of sequential tasks are language translation, where you translate a sentence from one language to the other, text generation, etc. And it is believed that they retain important information from a sequence. Now, trajectory planning is largely a sequential task because your current action can depend on what you've seen in the past. To give you an example of this, let's say your bot is driving in a narrow alley, and there is an oncoming vehicle. Now, since it's a narrow alley, only one car can pass, and so you have to sort of wait and see if the oncoming yields to you, then you can accelerate and go. Otherwise, you should yield to the oncoming car. And so there are a lot of these signals that you have to take care of, especially when it comes to driving. And so you need some sort of memory inside the architecture, and that is exactly what RNNs do. Um, and DeepMind actually published a paper called R2D2 in 2018, where they share their experience with, training recurrent neural network based RL agents in a distributed setting. So I sort of implemented that for Neuro's distributed RL framework.
Okay.
Should I move on?
Yeah.
Okay. And yeah, so until last semester, I'd only operated in the simulation world. So at Facebook, we were dealing with 3D simulated indoor environments, which were basically people's houses. And at Neuro, I was dealing with these scenes from self-driving car, but they were all in simulation. But actually, last semester, fall 2020, I got a chance to work. Give me one second. Yeah, I got a chance to work on a real physical autonomous vehicle, and I think the feeling of trying to control or interfacing with the car using your code or using your command line was something that was super new to me, and it was quite euphoric at the moment. So like when you can control the car with your command line, it's a really good feeling. um, and for the final project, I think so we programmed the autonomous vehicle to follow a selected object. And I'm going to show this video in which the vehicle is following our professor, David Forsyth. Yeah, so that was pretty cool.
Can this vehicle be also controlled using voice, like command, like stop, turn right, turn left?
Not yet. Not yet. Yeah. So it was a pretty basic autonomous vehicle equipped with, camera, LiDAR. Um, yeah, but it did not have like a voice assistant kind of a support.
Maybe you can add on to that.
Maybe I will.
Yeah. You,
So
I just saw the slides. You also had something to show regarding the Google internship and the Purdue one.
yeah.
I think we did not talk about that.
Okay. Let
You
me.
have something to say. What?
Yeah, 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 yeah. Let me try to present again. Can you? Are my
Yes,
slides?
yes. Your slides.
Cool. So I was a software engineering intern at Google in the summer of 2016, and there I worked on this project called automated user provisioning. Right. And so what is automated user provisioning? So Google has this service where it acts as an identity provider for third party applications. So let's say you have a company, and so your employees will interact with a lot of third party applications for productivity, right? They'll interact with Salesforce, maybe Office 365, so on and so forth. And so Google offered this service where it was like you make an account on the Google Cloud Directory. So you make your employees accounts on Google Cloud Directory, and it will automatically provision them. So when I say provision, I mean it will automatically sync them. So if you create a new record over here, it will be created in all these different apps that you have hooked with your pipeline. um, yeah, and if you like delete it on the Google Cloud Directory, the same changes will be reflected on all of these third party applications, so on and so forth. So I was working with the Google identity team, and they had built the second part of the pipeline where you could sync accounts from Google Cloud Directory to all of these third party applications. But the problem was somebody at that company, possibly the IT team, would have to go ahead and create all of these accounts on the Google Cloud Directory manually. And that is a very extensive process, especially if you have like a large company. So me and my co-intern, we basically built the first piece of the pipeline where we said, hey, now every company has their employee records stored in an HR database. So what if we just sync, we create another pipeline to sync records from that HR database to the Google Cloud directory? Then the entire thing is automated, right? So that is the work that I did at Google, um, provisioning users from HR database to the Google Cloud directory.
So any changes in either one of the database would reflect in other database, no?
Yeah. So any changes here would reflect changes here, and henceforth changes over here.
What about the security aspect of it? So can it be? Did you also consider that?
So I don't think we were heavily involved in the security aspect of it, because I think we worked on Google infrastructure. So Google has all of these bits and pieces, right? Like it has a big table for database, and it has all these different services that you can use, and they are, secure by themselves, and we just use them as the building blocks to sort of build this pipeline that we wanted to. So I don't think we had to poke around a lot with the security of things.
And actually, it got me thinking. Those last podcast we had with Shashank was like all
Yeah,
security related. So I was thinking,
yeah, and it was really interesting. But I didn't poke around with security in this particular project.
okay,
Cool. And let me also briefly talk about my research intern at Purdue. So I was a research intern at Purdue in 2017, and with Professor Bruno Ribeiro, and we were working on restricted Boltzmann machines. So this was a pretty theoretical project, and so what he had proposed was, there was a state of the art method for training restricted Boltzmann machines, or RBMs, and he proposed a different class of algorithms, and he hypothesized that they will work better for the training. So there are two classes of randomized algorithms. One is the Monte Carlo algorithms, and one is the Las Vegas algorithms.
right,
So the current state of art was based on Monte Carlo algorithms, but he said that if you use the approach of Las Vegas algorithms, the training will be better. And so I just conducted experiments to verify that hypothesis.
okay. Nice. So you have actually done a lot of interesting work and also in different areas of computer science. So coming from like software development intern at Google and also
Right,
a theoretical research intern at Purdue, then mostly MLAI related work.
right,
So,
right, right.
so which of these work like interested you the most?
Um, I definitely know that I'm not like a theory person. um, what I've realized based on all of these experiences is I want to work in application based systems. So, for example, my internship or residency at Facebook was this academic research, but at Neuro it was more applied because we were trying to do research for these self driving bots that actually go out on the car. Um, so, yeah, I think I've realized that about me, that I enjoy working more on application side of things.
Right, it's good. So even like even if you like train models and all, you need a good system for that. You need to understand the
Yeah,
optimization part and systems part, operating systems and all distributions and all.
right. So, yeah, that actually is a very good point. So, as I said, I enjoy working on applications more. That's basically because I want to see, okay, I did this work, but what kind of impact or what kind of change is it having in the real world? With academic research, it's difficult to do that because there, the work that you do has like a long term impact. But when you're in the application side of things, you can poke around with like real world systems and see what difference is your work making. And when you move to the application side of things, you're basically an engineer, and I realized that you need to have like strong systems skills, because I think of it, I think of ML as this tool to solve problems with unstructured data, right? All of this media that we have is unstructured, and so ML is a tool to sort of like extract features from it and then sort of do interesting things with these features. But when you build an application, there are a lot more things that are involved, right? You have to create pipelines for moving data, and how these different modules are going to interact with each other. So you have to debug things, you have to optimize things. A lot of things these days, they have to work in real time.
Right.
Latest
Mm.
example is like self-driving car, right? You have to process whatever you're seeing instantaneously in real time. So if you have an excellent ML system that has a very good accuracy, but it is not optimized for time, uh, you really can't use it very well.
Yeah,
Or you can't use it for applications that have these stringent latency requirements. And so when it comes, when you talk about optimization, you have things like parallelization, having a distributed fleet of machines to do, to divide up your work, have it done by machines. So having a strong foundation in systems actually, I think, helps you become a good, strong, solid engineer.
yeah, that's a really good point. So even like if you take other field as example for let's say something related to healthcare, you have a lot of ML models deployed there. So
Yeah.
you should have a high precision there.
Yeah.
So even accuracies won't matter there.
Right.
So
Right.
different kind of uh, scenarios require different.
Different skills, and you have to optimize for different things, different applications. Sometimes you can let go of accuracy, and you have to like really be hard on time, how much time it is taking. At other times, for example in medical, as you mentioned, you can take your time, but your results have to be precise and accurate. So yeah, I definitely agree with that point.
So, so what advice would you give the students out there regarding the
Regarding.
the research that work that you have done of the software development work in the, so what advice would you have, so how to build the fundamentals of what in the people who are in the second year, third year, or the final year, so what should they do to reach the position they want to be, whether they want to do a research work or whether they want to be a software developer, what would be your advice? So actually you have explored multiple areas so you would know better.
Yeah, I think it is very important to sort of do interesting projects. So let's say if you're interested in networks, try to pick up a project that will make you learn a lot about that area. Or so for example, when you pick up a project, you don't know what are the skills that are required, and so just the skill to sort of adapt and learn new things is very important. And that is developed when you take on multiple projects, when you take on projects from unknown fields. um, I'm not saying that try to do something random, but there are so many interesting things that we don't know about. And if we just take on a project from that will build these skills of learning and adaptability for us. And I think they help you out in the long run, like exploring things, how to find out how to do something, experimentation with things, being eager to sort of solve a problem, or knowing how to solve a problem, what are the steps you take. That is really important. The other advice that I would give is, uh, try to like get into open source, because open source, you're actually building software that is being used by a lot of people, and you will have these experienced software engineers who are contributing to the project as your mentors. They can sort of guide you, and you'll be working on a real world project. So the scale of that projects will be different, and you can have access to these opportunities that you would otherwise not at school.
Right.
Because like I think the scale of projects that we do at school is very small, versus the scale of projects when you go to industry, because there you have to support a certain number of users. And so the skills that you learn by working on an open source project are very much applicable to the real world and transferable. And they make you like a very good engineer, I feel. So yeah,
Right. You
soft
would be
open source, yeah.
glad to know that there are a lot of students currently in our institution that are doing a lot of open source projects and all.
And that's really awesome. I think when I was there, the community was like fairly small, but good to know that it has been growing.
So
I think I
both
would highly recommend that.
competitive coding culture and the open source development.
That's awesome.
So I think we'll take the Slido questions from now.
Okay.
Okay. So the first question that we have is, okay, how did you decide between a master's degree and a direct PhD?
Um, so I think I always knew that I would not be interested in, like, pure academic research, and that I wanted to be on the applied side of things where I work on a particular product. And so PhD would sort of take me the other way, right? Where I do
Right.
academic research and try to become an expert in one particular area. But that was not the path that I wanted to pursue. It was more like, you know, like I think in undergrad, I'd focused way too much on like these ML courses, computer vision, data mining, and I think I lacked that crucial systems knowledge, as I was mentioning earlier. And so I think masters, I still haven't done any research in masters. All I'm trying to do is like gap or cover that systems knowledge, and just try to become a good engineer.
So,
So for me, it was pretty clear that yeah, I did not want to sort of commit to that academic research, long term academic research, and that's why I chose a master's program.
even a good researcher needs to be a good engineer first.
Yeah, 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 yeah. No, absolutely. I agree with like the current state of things, definitely. Because things have to be optimized for like the current state of the current set of applications that we have. They demand like low latency and high throughput.
Right. Uh, so the next question that we have is, since you were already into a professional research at FB, what led you to decide you should pursue masters? So I think that pretty much answers what
Yeah,
you
I
have
was
said
doing
before.
academic research at Facebook, and I wanted to be an application based software engineer. So I decided to do masters.
Okay. Next question that we have is, how did you manage to get into both Google and FB? Any tips that might be useful for your juniors? Okay.
Sure. So I can describe the application process for the two of these. I think for Google, this was after second year, and data structures and algorithms is important because that is sort of like the screening layer for any of these jobs. Like
Right.
even when I'm interviewing right now, after my masters, the first layer is always being strong with your data structures and algorithms, having like a very clean um, coding cleaning having like a very clean approach to coding, thinking um, about
Clearly.
how you thinking clearly about how to solve a problem. So these you have to sort of become good at these, because they form like the screening process for a lot of these applications. uh, I think that was enough for Google because at Google there was only like technical screen, but for my Facebook AI residency, there was technical screen as well as a research based screen. So we talked about what kind of projects I've done, uh, what is it that I learned from it, what were the difficulties that I faced with it, what do I think is exciting moving forward. And it also looked up the profiles of different researchers at Facebook, what they worked on, and what I would be interested in doing. So I had answers to like all of their questions when it came to, okay, what have you done, like the projects, what have you learned from those, and what are you sort of looking forward to if you do get selected at Facebook. Yeah, so knowing about, so whenever you're doing something, do thorough research on what you're getting into, because you want to be a fit both ways. They You want to be a fit for Facebook, and Facebook has to sort of approve you as being fit in their own culture.
So what was the most important thing that you think led you to Facebook year residency?
I think the projects, yeah, the projects and the research work that I did with Vineet sir at IITH. I described all of that as a part of my research screening, and I was very clear as to what is that I understand what I'm getting into. Um, so I had read up the research work of people at Fair, and um, I had picked up some interesting bits to sort of talk about the projects that I found interesting.
So how was your overall experience at Fair?
My experience was really good because I think the work ethic of my team. So the most important thing that I've taken away from my fair experience is, how hard people work and what is the level of dedication that they have towards their work. So at we were at this point of time where we wanted to release AI Habitat, and so we would have like daily meetings where we would update where we are, how much progress we have made for our current task. So how do you manage your time? Having deadlines, realistic deadlines to help you stay on track, and just overall have like a very strong work ethic, and that helped me complete my Neuro AI internship. So my internship was very short; it was just for 9 weeks, and implementing a new architecture. So the second project that I worked on, right, implementing a new architecture in this code base that I did not know about. We were using, I think, TensorFlow version 1, and I was more familiar with PyTorch. So there were all these unknown factors, but like the things that I'd learned from FAIR about, how to prioritize things, how to manage your time, how to stay on track. So I would schedule daily meetings with my mentor at Neuro, and I did exactly what we did at Facebook, and that is how I was able to sort of complete such a huge project in such a short period of time.
Amazing.
Yeah.
Okay. Uh, okay. So, okay, there's some different questions. So, being in an organization outside India from a long time now, how did things change for you while you're working in a robust environment as yours? Did you get that question?
Uh, Wait, give me 1 second. Let me look at it. I think the question is sort of trying to ask me to contrast the
The
different
working in India or working in US,
environments.
I think.
Yeah. So as I said, I think the work ethic is pretty different. I've seen like um, a very strong work ethic in the US, um, and I just described that. I can sort of contrast the education in US, because after FAIR I've been studying, so I can sort of contrast the educational systems in US and India. Um, So I think the courses in UIUC are much more intense. Like we have a lot more programming to do. Obviously, it depends on the courses that you're taking, but I've been taking like very systems heavy courses like distributed systems, operating system. This time I'm taking security. Um, so there's a lot of like coding to be done. You have to build applications from scratch. Um, so the course load is pretty heavy. The second thing that I've realized is there's a lot of funding, right? So you can have a lot of infrastructure. There's a lot of funding for research equipment, and so there you can do a lot more interesting things. I think, for example, this one course that I'd taken, we were given access to 10 VMs, and all of them had like a very reasonable compute power. So having infrastructure, like compute infrastructure, as well as I think there are a lot more spaces for collaboration at US. Like you have all these areas where you can study together. I think that was something that I had sort of faced an issue with at IITH, because I don't think we have, or at least when I was at IITH, I don't think we have enough collaboration spaces.
Okay. Um, uh, okay, the next question is a little on the importance of connecting CSE alumni much more efficiently back to the folks out here. So, what do you think of the alumni connection at IIT? So I know it's not a old institute and it
Right.
started. So, how do you feel about the alumni network?
Um, so I think we there are ways in which we can make it stronger, because I think it's definitely helpful for us and the juniors,
Right.
because as I said, I think when I was working on my grad school applications, I received a lot of help from seniors, and um, we want to give it back to the university, right? Back to the institute, and especially when you're in your second year, third year, you're sort of confused about what is going on there. What does the trajectory look like? What are the things that you should do? What should the timeline for things look like? And And since we've been through all of this, we can definitely communicate that and reduce that uncertainty and give them like actionable feedback to sort of work on. Okay, these are the action items, this is what you need to do to sort of reach here. And we've also seen the career trajectories of different people around us, the people that we've interacted with, or we can connect you to people. Let's say you want to do something and we know someone who has done something similar, we can connect you there. The other thing is referral in companies. So if you want to apply for a job application, I think it's much better if you do it via a referral. And so let's say I worked at Facebook, right? And let's say you want to work at Facebook, or let's say some other
Yes.
company, you can reach out to that senior and submit like a referral, and you will get much more preference. I think referrals are processed more quickly, and the turn what is it? The acceptance rate is much higher when you refer someone. So these are the ways in which it will be helpful. And I think maybe we can have like some events, like maybe once a year or twice a year, where people can ask questions, sort of connect or bond with the alumni. I think that would be really helpful.
Right. Yeah, I agree. Like we can improve in this area a lot.
Yeah, are
And
there any events that sort of happen on a regular basis, maybe like once a year, twice a year, where the alumni and the current students interact?
yeah, we can have that.
I Do we have that right now?
Um, I don't think so.
Yeah, because I don't think I'm aware of any.
So even I did not receive any mails regarding it, so I don't know. But whenever a director or some person visits the university, they do call out like
Yeah, yeah,
alumni network meetup and all.
yeah. So, but it's just like the alumni, right? We're not
Right,
sort of reaching out to the juniors in the college. So, I think that connection has to be bridged.
right.
Yeah.
I hope after this podcast you will receive a lot of connection.
Yeah, I mean, like one event where the objective or the motive is to sort of, help out juniors. I think that would be really awesome. And if and podcasts like these, right, where alumni share their experience with certain things, I think that will also go a long way in helping students out.
Right.
Yeah.
Okay. Thank you. So, okay, another question was posted. So, how do you choose a research problem to solve? If the problem is new, what's the approach to start research on it so that it helps in getting a good publication?
Uh, to be honest, I've never chosen a research problem. So I've chosen which professor I want to work with, and then they have these different research projects that they work on, and I can sort of maybe like choose and pick over there. But I don't think I've started with like a, hey, here's a clean slate, what should I do?
Okay.
And then think about, I think I'm yet to reach that stage where I sort of try to devise the research problem.
So it's like you had some area of interest and then you chose the professor based on those area of interest.
Yes.
And with the help of professor, you chose a problem statement and worked on it and
Yes.
fine tuned and again.
Yeah. More often than not, when you're interns, I don't think you have, like, at least for me, I don't think I had a lot of flexibility in choosing who I was working with. Uh, at Neuro, I think my team was, so Neuro is like a exception to this, where the team was pretty open to my ideas and what I wanted to work on. So I just do a quick literature review, see what's hot in that area, what are people trying out, which things have like the best results, and maybe like, yeah, maybe I can try this for real world settings. So that is the approach that I took it for Neuro. I think at Facebook, I was assigned, so Dhruv, I worked with Professor Dhruv Batra. He was my mentor. He was my manager. And they had this very exciting problem, where they were working on embodied AI tasks. And I worked on some of those tasks initially. And then we rolled out into this big picture AI habitat stack. And I thought that was interesting and pretty relevant to what I'd done in the initial months. So that is how I sort of latched onto that project.
Okay. So I think This was pretty much the last question.
Okay. Mm.
So I'd like to thank you for taking your time out and giving us the
Mm.
showing us the presentation about all the work you have done and guiding the juniors on like there are a lot of opportunities out there. You should just
Yeah,
try
there
and
are.
explore.
Yeah. Um, I feel like just try to be aware. I think we have access to internet. Uh, we have access to, you have all these stories of alumni who have done wonderful things. I think Sneha Reddy from my batch, she did Google AI residency. Um, and I mean, like, I'm just taking examples of what I know. And there are a lot more people in my batch that are doing great things right now, and you can sort of decide which career trajectory excites you, and possibly, like, reach out to that alumni, or maybe ask Shikhar to invite that alumni to this podcast.
Definitely.
Yeah,
Yeah, sure.
cool, awesome.
Okay. So I would also like to thank the CSE outreach team to make this event a successful event. And
Yeah,
I'm hoping that more people like you and us will be available to talk and guide more juniors on the work they want.
yeah, I
So
mean,
thank you again.
yeah, thank you so much for having me.
Yeah. Stay safe, stay home.
Yeah, you too. Thanks. Bye.
Bye.